In this video, we'll start talking a bit about complex numbers. Now, if you'll recall, up to this point, we've always kind of said that we're not allowed to take square roots of negative numbers. This leads to several issues, the biggest of which is that we miss out on solutions to quadratic equations. For example, what if we wanted to try to find the zeros of x squared plus 1? Well, that would be x squared plus 1 equals 0. But then what happens? Well, then we would take 1 to the other side. But doing that, then, we want to take our own square root, and so we have x equals plus or minus the square root of negative 1. And again, so then we say there's no real, and that's the key word through all of this, solutions. But then the question is, what if this did give us a value, right? So what if we could take this square root? Well, this is a trick that mathematicians started using a couple centuries ago. And so, as such, we define the imaginary unit I as the square root of negative 1. So that's what we're going to call I, okay? Now, the reason that we call it an imaginary unit is to kind of stand against the fact that we know this can't be a real number, okay? Namely, by adding real numbers to the real multiples of I, we obtain complex numbers. Here, it's important to remember that each such number can thus be written in standard form as a plus bi. Okay? So going a little further into this, let's let a and b be real numbers. Then the number a plus bi is a complex number written in standard form, as we saw in the last slide. The real number a is called the real part of the complex number, and the number bi, where b is assumed to be a real number, is the imaginary part of the complex number. We further, so taking a bit of a step back, again, it's important to realize that you can sort of think of the real numbers and the imaginary numbers as sort of two halves of the same whole, which is the complex number. And this is sort of our more general understanding of what a number is now. When b equals 0, we then would have that this part goes away, and thus we just have a. That is, the number a plus bi would have to be a real number. And when b does not equal 0, it is an imaginary number. We further say that a number of the form bi where b does not equal 0, so in other words, what if a is 0 and b is not 0, then this is a pure imaginary number. And so we go further and also note that two complex numbers are equal to each other if and only if both their real and imaginary parts are equal. That is, we can say that this imaginary number is the same as this, that this complex number is the same as this complex number, if and only if the real parts are equal, a equals c, and the imaginary parts are equal, b equals d. So let's do some examples here. Let's find some real numbers a and b such that a minus b plus b plus 1 times I is equal to 6 plus 5i. Well, we know that a minus 2, for these two to be equal, this tells us that a minus 2 must equal the real part of this, and b plus 1i must equal 5i. Well, the i's would cancel, and so we have b plus 1 must equal 5. Okay? So that's matching up the real and imaginary parts. But then what we then know is then we can solve out, right? So that would give us a equals 4, and b would have to equal, subtract 1, 4 as well. Oh, sorry, add 2. So 6 plus 2, which is 8. So A would have to be 8 and B would have to be 4. If you'd like some more practice going through sort of these basics on complex numbers, be sure to see page 150, problems number 1 through 4 and 7 through 22. In our next video, we'll start talking about how to add, subtract, and multiply complex numbers.